What is string theory?
Yes.
String theory is an attempt to reconcile Einstein's theory of general relativity, a theory of gravity, with the formalism of quantum mechanics and quantum field theory. So it is a consistent quantum theory of gravity.
So why don't you start with that, Laura? What is the incongruency here that you're trying to resolve?
Two of the greatest intellectual accomplishments of the 20th century, in my opinion, are Einstein's theory of gravity and the description of fundamental interactions in nature as described by particle physics. So things like a description of, quarks, fundamental particles, how they interact with each other, that gives us a description of things like electromagnetism and the strong and weak nuclear forces. These sort of basic building blocks of matter, these fundamental Legos that we can hook together, they're described very well by quantum field theory. The issue, the sort of discrepancy between these two, is that each separately are able to make predictions that are incredibly accurate in our modern world. So we can make predictions to like 13 significant figures using either of these theoretical frameworks.
There'll be 13 decimal places.
But absolutely, there could be smaller things in play. And indeed, string theory posits that there are.
Okay. Oh, really? Okay, right, exactly. That's the little vibrating string.
So the string is the fundamental
thing. The string is the fundamental.
So take us there.
Okay,
Take us out. Now, how do strings come into this?
So the idea behind string theory, the 2-minute version of what string theory tries to do, is it says, imagine that instead of describing particles as little point particles that move through space, imagine that instead, if you were able to zoom in far enough, that you could have an object that has an extended length associated to it. Mm-hmm. And the very rough idea is that just like a violin string can vibrate in different ways and produce different notes, these little fundamental strings can vibrate into different configurations. And it turns out they can change their properties. The mathematics of how you describe these things moving can change their properties based on how they vibrate. So they can vibrate one way and be an electron. They can vibrate another way and be a quark. And that seems like a very sort of cute idea for how to describe a lot of physics in a very simple framework. So, before I answer that, let me just throw one thing out there about string theory that I think is important to say. So if you ask about quantum mechanical point particles and you say, what kind of spaces could they move through? It turns out that quantum field theory or quantum mechanics can be formulated in any type of space. So they can move through basically any background that you choose, any configuration of space and time. But if you ask the same question for these little one-dimensional strings, if you say, where can a quantum mechanical string move? It turns out that the only spaces that they're allowed to move in and do their thing of vibrating in different ways and being different particles, the only space they can do that in are spaces that obey Einstein's equations of general relativity.